So Don, there's a lot of interest in the cloud at the moment, and obviously that's the Azure platform from Microsoft. How does F# sit with the cloud today?
So I think the cloud is one of the really big opportunities for using F# and for seeing F# grow. There's two things I'd like to talk about the cloud. One is there's a misperception I think about the cloud that goes on. And one is people think, the cloud, we're going to have all these machines that we can do some computation on, and they start thinking, gosh, we'll start doing Fibonacci or start searching for prime numbers. They try and treat it like this, high performance computing. Let's use all those CPUs. But actually, when you think about what people are actually, the scalable services people are actually creating, they're not about doing computation with CPUs. They're about feeding information to the web apps that we all build today, or the rich client apps that we're building, or a standard Windows desktop app that happens to utilize an awful lot of the information that's coming through from the cloud. And cloud services themselves are all about, they can pull in data from other cloud services, maybe like financial streams of data or something, and be doing interesting kind of analyses of those. They can be pulling in those Twitter streams that we were looking at earlier on. They can be doing analysis and repackaging and republishing that information.
And this is just good architecture, good service orientation.
Absolutely,
stuff we've been talking about for years, right?
Yeah, and it's just in a more public setting, and in a sort of taking it out of the enterprise and making it into the cloud and getting the scalability that comes from the cloud. So I think people are overly focused about thinking about CPU parallelism, thinking about the cloud's a set of machines, and instead we just have to get out there and use it to build these scalable information-oriented services. And we've already, I'm mentioning that particularly because we've already seen how good F# is at for developing some of those kinds of applications.
And one of the themes I picked up on is the whole nature of working with immutable objects, working with inherently stateless objects, which obviously maps extremely well to the cloud, where you want things to be stateless, and you don't have to make everything stateless as an afterthought.
Yes, absolutely. You want statelessness, or if you do have state, you need it to be encapsulated and isolated, say within the processing of individual event streams, or some accumulations over the event streams we were looking at earlier. So one of the themes we've also been talking about is how the role of F# is, especially Visual Studio 2010, the role is about building these computational components that sit behind the sort of rich user interface apps. Okay, so we've seen that in Path of Go,
yes,
and in Project Emporia, and we see it in Bing, and also some of the more algorithmic kind of analyses people are doing with economic analyses and so on. And this carries across to what we envisage, how we envisage F# being used in the cloud. So we've got here Visual Studio 2010, and I've installed the Azure SDK, the Azure tools.
Yes,
for Visual Studio. It's actually not the Azure SDK. There's two.
Yeah, okay, so it's not standalone. It's the tools for the Visual Studio. Yes, absolutely.
Right. Okay, they're installed, standard Azure tools, and now we can go and create ourselves a new project here, and we can go to it's open up here, Visual C#, C#. Yeah. Go to Cloud and create ourselves a Windows Azure cloud service.
Okay.
Now, when we do this, we can start to choose the different roles that are going to be running in the cloud. Okay. We're going to have more than one role here. So let's just take a look at these, just so people understand what the cloud is about and what you can actually build with the cloud. So we're going to host an ASP.NET website in the cloud, for example, or the ASP.NET MVC2 is a different version of this, or we might be hosting a web service, and there are ones also build REST APIs in the cloud as well, not in this list, but you can go and get them separately.
Yes.
And then we can have, separately, we can have these worker roles, which are sort of background processing applications. And we can talk about those. And under here in F#, you can, there's a worker role here. You can define these background processing components and add them to your overall application. So we can add this one here, and we can add that sort of same ASP.NET role in C#. Right, so we've bring up our worker role here. So we've got our web role, we've got our overall cloud service,
Yep.
and this will handle the process of deploying to the cloud or debugging it locally on our little mini cloud that we can host on
the
our
dev fabric,
what we call the dev fabric
Yep.
of a local machine. And we have our C# user interface, the web app, and we have our F# worker role down below. So the great thing about that is that these things are just actually pretty simple. All they have is a run operation and an on-start operation, and that's sort of more or less it. And this is, yeah. So you just put the logic of your application, which you can have developed on. There's no magic here. Just the standard F#, say, event stream processing, and it can be hosted right here. Okay, so let's take a look at one of these that I've been working on lately. Okay, now this one's a bit different because what we're actually going to do is all the logic in this case is going to be in F#. So we're actually not going to be really doing a user interface in this case.
Right, so this is just a service.
Just a service, yeah. And this shows that you can do all the service just in F# alone.
Right.
So, first of all, I want to show how we prototype this actual service here.
Okay.
So the aim here is to simulate a quote server. Okay, so that means it's going to be listening to many thousands of clients, and there's going to be some. We assume there's some background process going on that's analysing these financial streams of information or information, say from Twitter streams or something, if it was another information server. And these clients come in, and we're going to feed. They open up TCP connections to the server, and then we feed them stock quotes at 1 second intervals. Okay. Now, because we're only feeding them at 1 second intervals, say down to the user interface, user interfaces, it's a bit like a chat server or something as well. It's a similar kind of balancing. This means we should be able to scale to each machine should be able to scale to thousands of clients, right? Because it's not a lot of work to handle each individual quote. Okay, so quotes are sent every 1 second, and the app should scale to thousands, and then we're going to prototype the code here and then move it over to Windows Azure. Okay, so we'll load up a couple of helper files. You'll be able to get these from the sample on the, which we'll make available with the video. Yeah. And let's run it first. Here's the code to serve stock quotes, and here's our server.
Brilliant.
And we'll skip over the clients. So this is all in F# interactive. Just so we're actually going to be prototyping the full network of 5,000 clients and an individual server serving those 5,000 clients just on our local laptop, right? Just while we're on the plane or something like that, get it kind of working in the local setting. Okay. Absolutely. So now we can start up the clients. Take a while to start up. And you can see that we've got our 5,000 clients running, and they're busy talking to the server and receiving these streams of quotes. And every now and then they report, I think after they get 30 quotes, they decide to report back on something in a round robin kind of way. Okay. And they're meant to be getting kind of 1 quote every second, but they're on this situation, there's just they're getting a little bit below that because we're starting to stress the system just a little bit, as you'd expect for 5,000 clients. Now what we see here is this wonderful language feature in F# called F# asynchronous programming, which lets you create these lightweight threads, effectively lightweight little what we call asyncs or agents or tasks or the like, which whenever they go to sleep, so maybe whenever they're say waiting for the next quote to come in, so the client is there waiting for that, waiting, 2, 3, like this going through. Then that's a lightweight wait. You're not blocking a thread. The continuation for the computation is scheduled and stored away with an event callback. And so it's sort of callback-based programming, but it lets you write your callback-based programming in exactly the way you want to write it. So let's take a look, for instance, at. So both the client and the server are written using F# async. So
Okay.
this is the server. This is the full server code for this application here. I admittedly, some of it's hidden behind this generic class of an async TCP server, which was defined in the helper file, but this is totally reusable.
Great.
So this just says what IP address we're going to be listening on the local machine. We've got a port number here.
Yep.
This says what we do each time we get a client coming in.
Okay.
So we're going to serve stock quotes to the client. And there's a little thing here to help track the requests. This is probably not strictly needed. Right, so let's take a look at what serving stock quotes means. Now remember, we're going to be running 5,000 of these at once because we're going to be having 5,000 clients. So that means we don't want 5,000 threads, okay? Because that will kill our server. Okay, 2 megabytes of stack per thread, and your machine's dead. Okay, but we can have 5,000 of these running because they don't block threads. Okay, so let's just read off what they do. Nice and declarative. We've got a TCP client coming in. We get the stream. We write some header back to say who we are or something, and we just assume that's a header.length. This is just a mock service. And then we write a quote, and with a quote length, and then we sleep for the time between quotes, which is going to be 1 second in this case. Okay, so remember, whenever you see these bang points here inside this asynchronous programming, that means it's potentially a lightweight sleep. So it could take the rest of the computation and just put it away and go back to sleep. And if we actually look at the number of threads running on this app, manager here. So this app has got only 35 threads running.
Yet it's serving 5,000 clients.
Simultaneously. It's got the 5,000 clients and it's serving 5,000 clients. So that's actually like 18 on each or less, right? So the bits and pieces of work are being multiplex tasks between those various threads, because those threads can do a lot of work in the time that's got available.
And this is something that is out of the box in F#, and presumably would actually involve quite a lot more code if you were to do this in another .NET language. This
would involve really a lot of code. You could follow a similar structure using the task parallel library. You'd imagine that this would be task.continue with, task.continue with. There's a while loop. I'm not quite sure how that would go. That would be so I have to structure that slightly differently. And so you can translate this into TPL, but obviously it's very clear and simple for here. And you can if you did want to have, if you for some reason you did need to have a single thread serving a particularly important client, for priority reasons, then you can clearly just get rid of all the bangs and change these to synchronous writes, and you're back to your synchronous threaded code.
So anytime you're looking at serving a large number of asynchronous operations, this is actually potentially a very good way of dealing with that.
Yeah, so it's great for for getting the local machine to scale. And it's also great in user interface settings where you've really only got one thread of computation and you don't want these needless background threads just to do I/O or something like that. So it's really good for Silverlight programming, for example, as well, if you have some complex interactions with the with the server components.
Indeed.
Okay, so, and the clients look kind of similar. You can see here the main client loop. For each client does a get stream, it does a read. You just replace the writes with reads on the other side of the protocol, and then you do some printing out every now and then.
Great.
Okay. Right, so let's kill off our 5,000 friends. And let's go look at our worker role here. And what I'm interested in here is just how little everything changes here. Here we have our worker role, and it's just like what you get with the standard template. We've got our run method here. So the aim is, hey, suddenly we've been successful with our service. We want to go beyond 5,000 simultaneous users. And we want to scale to 500,000. We get that boom in our internet business.
Exactly, it's Christmas or there's some peak of activity.
That's right. Or take another situation. Maybe you could only maybe you're doing something more intensive on your client. Maybe you're serving images or something, or video even. And that means you've only got, say 50, you can only handle 50 per machine.
Okay.
And you're going to hit that point where you need to scale.
You're going to hit that much sooner.
Quite quickly. Yeah. So here's our worker role. And the important thing is this code is essentially the same. Here we have serve stock quotes. It all looks very familiar. Get the stream. So this is just our code which we've prototyped, pasted into the cloud worker. And what changes? I mean, let's take a look. We're still using our async TCP server class to define the server, same class. All we've done is we're just using a different TCP connection. We ask our environment for our role, current role instance, get the endpoints, and say, give us the address that we should be serving to. Because what's happening is Azure's handling the whole process of load balancing. You have a particular TCP port coming in. Each of the workers have to, from the outside, it looks at that like it's that stable TCP name. And each of the workers just have to be told which TCP port they should be talking to within the local load balancing. And besides that, we have the same business, server.run. Of course, the clients would be actually running its real world processes, talking to the connection. And we've got our scalable service will be running in the cloud. Okay, so what we're going to do now is run what we've the cloud service that we've created here on the local development fabric. So we're starting that up now. We have our display for the local development fabric here. We're starting it in debug mode in this case. So this is fantastic.